Okay, so hi there, folks. It's been a long time. Here I am again, Sir A. I'm going to present to you numerical summaries of data. So this is part of our playlist in the introduction to statistics. Anyways, this video will be something like a PowerPoint presentation of how to get numerical summaries of data. This will be in two separate videos. Take note that statistical softwares are not used in this video since this is a PowerPoint presentation. Kindly see my other videos for the statistical softwares. I will always refer to them whenever I can during the span of this video. So again, this is the numerical summaries of data. So before we even start, we need to understand some key points or definition of terms before anything else. We need to understand the definition of a measure. So a measure in statistics is a numerical representation of a particular characteristic of the data set being studied. So every time you get something, you summarize the data set. You represent them in a single number. The data set, it will be called as a measure. A parameter is a measure which is taken from the population. So we call that parameters. Okay, any measure from the population. They are usually represented by by the Greek letters or Greek alphabet. When you take a measure which is taken from a sample, we call that a statistic. Don't get confused with the name of our subject. Okay, it doesn't have an S for singular. If it's plural, it will be similar to the subject statistics. But take note, it will be a small letter because the subject statistics is going to be a capital letter. So it's any measure taken from the sample. It is usually represented by English or by the English alphabet. So we recall that statistics is a branch of mathematics that deals with, or a branch of science or another discipline that deals with the collection, organization, presentation, analysis, and interpretation of numerical data. So hence, we need to know how to summarize numerically because we are dealing with numerical data in statistics. So I want to first introduce to you some symbols for parameters which are used and some symbols for the statistic or statistics. So for the population size, we use the big N or the capital N for that. Population mean is the mu. This is your Greek letter mu. Sample, or rather population standard deviation is your sigma. The variance is your sigma squared, and you have your population coefficient of correlation, which is your rho or your Spearman rho, as if you want the full name. So those are examples of parameters, measures taken from the population. Notice that most of them are gonna be Greek letters or are Greek letters. For the sample or statistics, the sample size is the small n. We know our sample mean is x bar. Our sample standard deviation is S. Some books use SD, but we'll use S here. For the sample variance, it's S squared. And we have the sample coefficient of correlation, which is your R, or you may call it the Pearson R. It's also by Carl Pearson, or its long name if you want, the Pearson product moment correlation coefficient. But let's just call it Pearson R for now, so that will be okay. So notice the difference of the symbols for parameters and statistics. Okay, so we'll talk about first, as we can recall, there are two types of data. We have qualitative data and quantitative data. So for qualitative data, we must understand how to summarize them. Since they are qualitative, so we are somehow limited in summarizing them via proportions, that is relative frequencies, or percentages. So imagine if you are talking about gender, say you are talking about sex here in particular, and we will code male as 0 and female as 1. As you can see, it's very inappropriate to get the general average of the gender, or the gender average, shall we say. Um, we cannot also add male and female, add plus male and female, we cannot times them. But what we can do is to put proportions or percentages of females or males at the group. For instance, we will use proportion or percentages. Say 2 out of 10 students are male, or we can say that that's in proportions. And for percentages, you can say that 20% of these students are males. So those are examples of how we summarize qualitative data. Now, for that's actually all that is there for qualitative data. There is not much that we can do. We just need to proportion them or get the relative frequency and then the percentages. Now let's move on to summaries of quantitative data. This slide will particularly talk about, or the next batch of slides will particularly talk about how can we represent a data set or a group of data into a single number in such a way that that number will represent the other parts of the data set or the group of data. So we will be taking into consideration their average. Okay, so that is the number that will represent the whole group. Okay, so that's what we call the average or the centermost number. These measures are what we call the measures of central tendency. So these are the measures that can be a representative value of the data at hand. So they are also called measures of central location. Some books would like to call it measures of centrality. They're the same. Like I said, it is the representative value for the data set, the values around which most of the data points are found. That's also the definition for the central tendency. They are also called averages. And there are three main types of measures of central tendency. We have the mean, median, and mode, the most famous mean, median, and mode. So let's talk about the mean first. Now the mean is actually just literally the average. All right. So how do we do this? We just need to sum up all of observations in a sample or in the population and divide the sum by the number of observations we have. So it represents the center of the data and also called the center of gravity or expected value in some contexts. So if you see this term, expected value, it will actually just be the mean. So the most important measure if it is or the distribution is symmetric. So notice if the distribution is symmetric, it's the most important measure to use. Just take note though that if your n, your sample size, is small, the mean is very sensitive to extreme values. These extreme values are what we call the outliers. Okay, so I will show you an example of why that happens. And if ever there's a question that will be asked from you, what is the most stable measure of central tendency? The answer will always be the mean. Okay, so the answer will always be the mean. So let's see the formulas here. The formulas for population mean and sample means are similar. As you can see, the left-hand side is only the difference in the population. As we all know, we're going to make use of Greek letters. For the samples, we make use of alphabet, English alphabet. So what does this mean? You just need to sum up by the summation symbol, sum up all the excess, wherein I is equal to 1, 2, 3, up until the last number. So you sum up all the excess, all your data values, and divide them by the total number. It's either population mean or population size or sample size, depends on your context. So that's how you get the mean. So for instance, say you want to have this example here, a particular quiz generated the following scores of 8 students in a class. So we have 8, 11, 5, 14, 8, 11, 16, 11. So consider the quiz as the statistical population of interest. So what is the mean score? So what we need to do is to get the mean. So this is manual. We'll try to do it manually since uh, if you want the software. So there's another video for that. I'll give that to you in a while on the descriptions below. So divide them by 8. So manually computing, what do we have? This becomes 19, 24, 20, 38, 46. And then what we have is 57. And then what we have is 73. And then what we have is 84. Let's try that again. So we have 19 plus 5 is well, rather, yeah, 24 plus 14 is going to give us 38 plus 8 is going to give us 46 plus 11. Let's add two 11s. 48 plus 22 is going to give us 22 plus 48 is going to give us a 70, and 70 plus 16 is going to give us what's that? 86 or 84 rather. Okay. So you can check that again if you want. I can say that maybe this is correct, maybe I'm wrong. So what's this answer? So 84 divided by 8, it's gonna give us. So this becomes a 10, right? There are 10 eighths in 80, and then we have 4 over 8, which is 1/2. So the answer is 10.5. Okay, so that's the average mean score of 8 students. So take note, for reporting purposes, one generally reports the measures of location to one additional digit before the original level of measurement. So notice that we have here um, 8 numbers. So we want to extend one place digit beyond that original level of measurement. So since they're all in the ones digit, we're going to add one to the 10th digit. All right. Now, that's how we get the mean, simple as it is. For the weighted mean, this is another type of mean. The previous one is what you also call as the arithmetic mean. For the weighted mean, it's similar actually. This is how you get your weighted average if you are talking about the grades. So it is a mean which each value is weighted according to its importance to the data set. So the more important it is, so the more weight it will have. So for instance, so the formulas for the population and sample means are the same. So it's just like this. So you just put the subscript, which is W, just to tell it's a mean, but it's weighted mean. How do we solve this? It's the sum of all the products of W and X, W sub I and X sub I. So let I to be 1, 2, 3, and so on. So we have the weight of I times the value of I. You get the product, and then you sum all the products, and you divide it by the sum of the weight factor. So operationally, if you want the textual definition of how we do this, so we first each value in the group X is multiplied by the appropriate weight factor, which is W, and the products are then summed and divided by the total sum of the weights. So for instance, if we're going to apply weighted mean over here, so what is the average for a student who received the grades of 85, 76, and 82 on the 3 tests and 79 on the final examination in a certain course if the final examination counts 3 times as much as each of the 3 tests? So we can put here, say grades. We have 85 here, we have 76, and we have 82. But notice that we have 79 over here, and the weight of each of the grades. So this is test 1, this is test 2, this is test 3, and this is a final examination. I'll call it FE for final examination. So since the weight of the final examination is 3 times the weight of the other grades, so I'm gonna put here 3 and then I'll put 1 for all the others to make our lives easier. So and then what we're gonna do is this is actually your X, this is W, actually your W, your weight factor. And let's multiply them by what the formula says that we need the WX. So 85 times 1 is 85, 76 times 1 is 76, 82 times 1 is 82. How about 79 times 3? So we have times 3 here, right? So 21 we have, and then 27. So what do we have? It's 237. So hence the sum is, or rather the product of 79 times 3 is 237. Okay, now what we need to do then is to get the sum, the summation of wx, because we need to get the summation there, and then we're going to divide that by the sum of the weights, and then we'll get the weighted mean. Okay, so let's say this is a sample, so we'll use x bar w. So what's the value? So what we're going to do is to sum up also the weight. So we have 1 plus 1 plus 1, 3 plus 3. That's going to give us 6. And then we're going to sum up all the products of w times x. So that's going to be we have 2 here. This will become, I think, 4. We have 8 plus 7, 15. 15 plus 8 is going to give us 23. 23 plus what do you call this? 23 plus 3 is going to give us 26. So pretty much there's a 2 here. And then we have a 5 plus 11 plus 6 is 11. 11 plus 2 is 13. 13 plus 7 is going to give us 20. So we have 0 and we have 8t here. Okay, so we have 480, and then what we're going to do is to get this, this becomes 480. So that's the sum of all the products of W times X. And we're going to divide it by 6. So what's the answer here? So is 48 divisible by 6? So we have 4, 8, 12, 24. Yeah, it's 8. 8 times 6. So that's gonna be 8, 80 over 1. So that's gonna give us 80. So meaning this student's average grade is going to be 80, which is still acceptable. Okay, and that's his grade in this example. Now, next is the median. The median is also one of the measures of central tendency. We're gonna discuss that a little bit. So, the median, it divides the data set into two equal parts since it's the center of the array. So, if whenever you get that median, it will divide the data set into two equal parts. It is not sensitive to extreme values or to outliers. I'm gonna give you one example later and illustrate that. Useful for summarizing skewed distribution. So this is for skewed distribution. First and foremost, the symmetric distribution is good for the mean. Data must be at least ordinal. Okay, at least ordinal. And then if your n, your sample size or your population size is odd, the median is the middlemost number since it's odd. So there should exist an exact middlemost number there. If your size, or sample or population size is even, so the median will be the average or the mean of the two middle values. Okay, so let's have this again. Population median is denoted by this, and the sample median is denoted by these symbols. So this is symbol somehow cut. It should be a tilde like that, or X tilde. Okay, so mu tilde and X tilde. So recall X bar is what you call your mean. X tilde is what you call your median. Okay, so we have those symbols to help us identify what we meant by the what are we going to take what we meant by those symbols. So as an example in median, we're going to tap on the previous example that we have. First, we need to make sure that it's formed in an array. It's the middlemost score, but the distribution should be in an array. It's either ascending or descending order. The thing is, you need to take the middlemost score, and say we have 5, 8, 8, 11, 11, 11, 14, 16. So it's already from here, it's already in an array, but we need to take the middlemost. So since there are 8 of them, they're even. So we need to get the fourth and the fifth number, 1, 2, 3, 4, and the fifth, and we'll get the average of this two numbers here. I think that's obvious since they're both the same. So meaning if we're going to get the average, it's going to be 11 plus 11 divided by 2. That's silly, so that's going to be 11. So meaning our median over here, everyone, is equal to 11. Okay, now we came to a point, we now come to a point wherein we try to what do you call it? Compare the mean and median. So take a look at the dot plot given here. So the note, recall that your mean, your x bar is equal to 10.5, and your median x tilde is equal to 11. So they're pretty much close to each other, relatively close to each other, given that setup. And the mean and median values would be considered to be good representatives of the data set, since they are located at the center where most of the points are, which is true enough from this graph. Now let's try to ponder upon this, and let's try to think, what if instead of 16 as the highest number, the highest value is 160. So then the last point of the dot plot would be very far from the rest of the points. So it's like they have 11, three of them are 11, we have 14, and after 14 we have 160. So the dot plot would be very far away of the rest of the points, or we have an extremely high value, which we call outlier. If we ever gonna draw the dot plot, so the point of 160 is gonna be far away. So let's take a look at the solution. If ever there's an outlier, which is 160, for both mean and median. So for the um, mean first, we will try to add up all the x's, including the 160, and that gives us 28.5 for our mean. Okay, whenever we um, we add all of those in the array and then divided by 8, that's going to give us 28.5, okay, for the mean. And for the median, the answer is still intact. As we can see, it's still 11. So what's the key points here that we can see? One thing for sure, you change the given from 16 to 160, so therefore that's an outlier. So we can summarize the remarks by taking a look at these statements. The resulting value of the mean is not found at the center where the points are mostly located, while the median remains the same. So notice the mean is not found at the center, but the median remains the same. So that's one thing that we can see after solving such. The value of the mean is then affected by extreme values, or we call them outliers in the distribution. Hence, it cannot be used to represent the distribution if the shape is skewed. So if the distribution is skewed, it's quite impossible or quite troublesome or erroneous to make use of mean. Okay, especially if it's very, very skewed. So that is why one condition for its use as a representative value is that the shape should be symmetric at once. On the other hand, the median has not changed. I think that's obvious because the only middle value um, is the one which is being watched upon. It's the one being checked upon. So or located upon. So the extreme value is not used in determining the medians. Hence, the answer for the median is still the same. So therefore, whenever we have a skewed distribution, actually a very, very skewed distribution, if ever we have that in our experience, I think it's better, or no, not I think, it's better. Okay, it's more proper to use the median instead of the mode. Okay, especially if it's very, very skewed. Okay, now with that, let's go on to the mode. The mode is the last one. So the mode for me is the most popular measure of central tendency. It gives us the highest frequency. The one with the highest frequency, you just need to count it using the naked eye. It can be applied in any measurement level, and it may also not exist. And if ever it exists, it may not be sure that it is unique, meaning there's only one. So the mode is related to the concept of peak or peakness or peaks in a frequency distribution. So when you say unimodal, it's a single peak. So you can imagine a unimodal graph to be something like this. There's only one peak, which is the highest score over here. You could also have bimodal or trimodal. So I think you can understand bimodal. There are two bulks there. Wherein the topmost values are the modes. We can also have trimodal, like 1, 2, 3. The thing is, all of them have values which is the same, which is the highest. So these are unimodal, bimodal, trimodal. I think you can continue the list. Okay. So population mode, we have this symbol for the mode, the mu hat and the x hat. So I hope you can memorize that, everyone. So that's x bar is equal to your mean, x tilde is equal to your median, and x bar is equal to your mode. Okay, for easy memorization and easy way to look at symbols. So going back in this example, using the naked eye, we can see that the since it's a population, so the what do you call that? The mu hat is going to be 11, since 11 is the only number which appears more than once, or appears the highest with the highest frequency. Okay, so our mu hat or our mode is going to be 11. Well, what if there are 9 students and the score of the ninth student is 8? So what will happen? So notice that the number of 11s is now equal to the number of 8s. So what we're going to do, we're also going to consider 8 as a mode, and they're a tie. So this is an example of a bimodal distribution. So you can imagine this is 8 here, for instance, and there is 11 here. So it will peak on 8, whatever it does, it will peak again on 11. Okay, so it's not the best drawing out there, but I hope you get the point that uh, they are related to peakness. All right, now we're done here. In the central tendency, again, we have talked about the mean, the weighted mean, the median, and the mode. Now, I want you to see very briefly the relationship between the mean and the median. And this is related to the shapes of the distribution: symmetric, positively skewed, or negatively skewed. So for the symmetric distributions, that happens if your mean is equal to your median. So this is um, um, a very rough and easy way to determine the skewness of a graph without even constructing one. So positively skewed, this happens when your mean is greater than your median. And negatively skewed, this happens if your mean is less than your median. So pretty much straightforward, you can determine now the shape of your distribution by making use or just, checking onto your mean and median, the values of your mean and median. So that ends my slide today. It's quite a long slide talking about the measures of central tendency. I will be creating the measures of variability very, very soon, and I hope you would stay tuned, leave a like, please. And then if it wouldn't hurt, kindly click subscribe. Okay, so thank you very much. See you in the next video.